Now that we've seen how you can implement LCS in theory, we're going to go ahead and go through the code on how you can implement the longest common subsequence. And we're going to basically go through each step of the code that we're going to write, understand what is happening at that point. So now the first thing we need to do is define a function. In this case, I've called our function LCS, and the function takes in two parameters, takes in x and y. And this x and y are going to be basically the strings that we pass, in. If you go back to the theory that we wrote here, we have the two strings from person A and the one from person B. Those are the ones that we're passing into this function here. So the first thing that we do after this is to go ahead and set up our variables. So we're going to set up two variables, one called m and another one we'll call it n. And all this, the only thing they do is they check the length of the string. So n is going to represent the length of x, and m is going to represent the length of y. Now that we have these strings set up, basically they just measure the length. And so, for example, for A, if we go by the strings that we had earlier here, so A has a length of 6 and B has a length of 7. So that's what it's going to basically give us. The next step that we go from here is we need to create a two-dimensional table, and basically the two-dimensional table is going to be n plus 1 by m plus 1 in size. So these are our table. Like you mentioned, you need to create a two-dimensional table, and that is what we're going to go ahead and do. So we're going to create a let's store what it returns here, and we're going to have, so in our table, basically, what we're going to iterate through the numbers. Then we're going to basically return 0 multiplied by, let me just write this and then I'll explain it in a moment. Then we're going to have m plus 1. So remember, m is the length of one of the strings. So we're going to return this for underscore in range, and the range is n plus 1. So this is what we are returning. So basically what this line does is that it creates a two-dimensional table of list of lists, as you can see from the code that we've written. And it has the size of n plus 1 by m plus 1. Each cell in the table is going to be initialized to 0. And we've already set up that here. So each cell is going to be initialized to 0. And why we choose the size of n plus 1 and n plus 1 by n plus 1 by m plus 1, why we choose a size like that is because we need some space to compare up to the full length of both strings. So the one that has, one of the strings has a size of 6 for, in the example that we've seen, another one has a size of 7. So whatever the size of the string is, so we're going to basically compare up to the full length of that string, and we're going to add an extra row or column that is going to handle a case where there's a string that is empty, or there's some empty string somewhere in the text that we're dealing with. So now that we've done that, so initially what it's going to look like, from what you've set up here, we're going to have a table like this, but each of the cells is going to have a value of 0. So that is ideally what you've done with this first set. So after doing that, the next thing we'll go ahead and do is fill in the table, and you can use this nested loops to basically do that. So you can just have a for loop for i in range from 1 up to n plus 1, should be 1. And then for j, again, since we are dealing with a table, we have the two dimensions we have to take care of. So hence we're using two for loops here. And then we have 1 and m plus 1. So we have these two for loops, and so where each loop is going to iterate through both of the strings, starting from I equal to 1 to n and j equal to 1 to n, both of the indices that we've described there. After doing this, we're going to now check if each of the characters match the characters for both of the strings that we have So to do that, we just need a simple if statement. So we'll have if, and we're going to start with x. So we're going to start with the x and y, which we had already defined earlier. And I think what I'm going to do here, so that we avoid a lot of confusion, let's make this capital X and capital Y. It's going to be easy for readability, and also just reducing any other confusion that might come up when you're comparing it with the other variables that we have declared here. So, which makes it easier now on this end. So we just say if x, and we specify now the cells. So I minus 1, if that is equivalent to y. So we have y and j minus 1 at j minus 1. So if each of these characters match, that's what you're doing here. If the characters match, we're going to go ahead and do, so we already wrote these formulas here, and this is for when the characters match. We basically do this here. So we're going to go ahead and have dp. So we'll have dp index I, and we're also going to have index j. So we have both of them. And so this is what we're assigning. So what we're going to have is I minus 1. We have I minus 1 and j minus 1 plus 1. So just the entire formula that we had already defined earlier. So if the two characters match, we take the value from the previous diagonal, and the previous diagonal cell in this case is what we have here: dp I minus 1 j plus 1, basically that. So we take the value from that, then we add 1. This is when they match. When they don't match, what we had defined earlier is we take the maximum basically sequence that we have up to that point. So if the maximum sequence up to that point is 1 or 2 or 0, that is the value that we're going to carry on to all the other cells that do not match. So we're going to add 1 for the case that it matches. So if it reflects, we get that. So an example is if I is equal to 1 and j is 1, then in that case, let's say we have the cell at 0. So both the x and y axes are matching. If there's no match in that, then we basically choose a value to go with. I do hope that makes sense. So the next thing we're going to do from here is, this is now in case there's no match. So we'll have an else here. What we'll do is just going to have same thing that we've had. So we'll have I, and we're going to have j here. But now we basically take the max. So the maximum sequence that we have up to that point. So the maximum sequence of dp at I minus 1, and then we're going to have j here, and then we have dp at I and j minus 1. So this basically checks the maximum that we have on either. So if basically what the first one does is it checks the cell above. So if the characters don't match, we take the maximum value from either. So this checks the cell that is above, and this one checks the cell to the left, and ensures that we keep the longest possible subsequence, the length that we've found so far. So after basically filling everything with what you have here, we're going to have a table that looks like this. In a case where assuming the strings that we're using are the strings that we have already defined here, where we have string A and string B. And the final thing we're going to do after doing all these calculations, yeah, or rather all these operations, is going to go ahead and basically return the length that we have, the length of the LCS. So we'll go ahead and return dp at index n and m. Again, the reason we're doing this is because the longest common subsequence is always going to be the final number that we have at the last cell here. So as the bottom left rightmost cell that we have down here, this is always going to be where we can find the final length. So that's why we return it like this. And let's give it an example usage from what we had earlier. So we had x. From what we had earlier, x was, let's go ahead and pick this. So it's a string, and we have y, and our y was this next one here. So we're going to pick both of the strings, and then we'll just print the output that we get from this. So we'll just use a string here, and then just say the length of LCS. Let's just say LCS is, and we're going to call the function LCS and pass in the two parameters. In this case, the arguments are going to be x and y, like that. So with this, we should be able to get an output. We don't have any errors so far. Okay, we don't need any of this. That was just an auto completion that we didn't need. So now they should work. Right. So just run our code, Python 3 longest common subsequence. So you can see we're getting the length of LCS is 4. It has done everything for us. And if we refer to when you are doing everything manually in our table, we got 4 as the final value. And that's basically a Python implementation of the longest common subsequence from what you've seen so far. So now the other thing that remains to be discussed is basically the time and space complexities of both of them. So the time complexity is of this dynamic programming solution will be O of n plus m, where we have n and m at the length of the two inputs. So the two input strings that we're using, x and y. And the reason for that is because we use two nested loops, and one iterates over the value of x, rather the length of x, and another one iterates over the length of y. So for each combination of I and j, we perform a constant time operations, which are basically comparison and assignment. So now that makes the total time taken in proportional to the product of the length of the two strings, which is now we have n and m. So the term complexity is going to be of n by m, so n times m. Let me just write it here so you can have it as a comment. So time complexity is going to be O of n and n by m, like that. So that's going to be the time complexity, same as the space complexity as well. So the reason why the space complexity is because, again, we're storing the results of the sub problems in a two-dimensional table, and in a two-dimensional table that has a size of n plus 1 by m plus 1, the table basically holds the integer values, and the space that is required grows with the product of the input size. That's why we also have it like that. There's a way that you can go ahead and basically look at space optimization in deeper details, but I'm not going to do that today here. So I hope all this made sense. If there's a question, feel free to ask, and cheers.